Hello, BSRT2 students. Welcome back to our virtual classroom. By the way, Happy New Year. So it's already 2021. And sad to say, natapos na lang yung 2020. Wala man lang chance na na-meet ko kayo one by one. Hindi ko pa rin kayo kilala. Most of you until now, ano? So this morning, we are going to discuss radioactivity. And I guess you already have an idea about radioactivity since mostly, or there is a song, Radioactive by Imagine Dragons, and may mga na-discuss kayo way back when you were in high school, kunwari lang ka mo mayabas, din summer, nakinig naman kayo sa teacher niyo. I guess you have an idea what is radioactivity. Okay, so the last time, we have ended up with our discussion with the four fundamental forces of nature. So, given the four fundamental forces of nature, the gravity, the electromagnetic force, the strong nuclear force, and of course, the weak force. And we said that among the four fundamental forces of nature, so, isa doon ang responsible for the conversion of an atom from one form into another. So, that is attributable to the weak nuclear force. Hindi naman pala lahat ng weak masama. Okay, so because of that weak nuclear force, meron tayong radioactivity. So far, you have learned that among the four fundamental forces of nature, such that when an atom converts from one form to another, or the decay, it is most likely attributable to the weak nuclear force. In this module, we would investigate further how these atoms decay from one form into another, the physical characteristics of the atom, as well as the processes involved in the decay process. So before we start with our discussion, I would like you to get a periodic table of elements. Kasi hindi natin ma-understand mostly yung conversion ng one form ng atom into another without the aid of a periodic table of elements. In 5, 4, 3, 2, 1. Okay, very good. You already have your periodic table of elements. But before that, again, before, so we would like to have first our pre-test. So, get a piece of paper, a pen. Of course, we are going to answer only 10 items. Later, we are going to check if your answers are right. Or, if wrong, mako-correct din natin yon. Okay, so let's have the first item. Electron capture has a similar result with blank emission. Is it letter A, beta minus? Is it letter B, beta plus? Letter C, alpha, or letter D, gamma? Number 2. Emission resulting when a proton undergoes conversion into a neutron. Letter A, beta emission. Letter B, alpha emission. Letter C, beta plus emission. Or letter D, gamma emission. Next. Cobalt-60 decaying to nickel-60 is an example of letter A, beta plus decay, letter B, beta minus decay, letter C, alpha decay, or letter D, electron capture. Hindi ko na alam what number to. So, the following emission tends to decrease atomic number by 1, except, is it letter A, beta positive decay? Letter B, beta minus decay. Letter C, positron emission. Or letter D, electron capture. Which of the following is least likely to undergo radioactivity? Is it letter A, cobalt-59? Letter B, uranium-238? Letter C, carbon-12? Or letter D, Radon 222. Next item. The following subatomic particles determine the stability of all atoms. 1. Proton. 2. Neutron. 3. Electron. Is it letter A, 1 and 2 only? Letter B, 1 and 3 only? Letter C, 2 and 3 only? Or letter D, 1, 2, and 3? Next number. It is the Auger electron emitted during the electron capture. Is it letter A, K-shell electron? Is it letter B, beta plus particle? Letter C, characteristic radiation? Or letter D, a proton converting into a neutron? Next item. Blank is an electromagnetic radiation released during transition of a daughter nucleus from an excited state to the ground level, energy level. Letter A, alpha. Letter B, gamma. Letter C, beta. Letter D, X-ray. The radioactive disintegration that results in characteristic radiation. Is it letter A, beta emission, beta minus emission? Letter B, beta plus emission? Letter C, alpha emission? Or letter D, electron capture? Next number. Which of the following decay modes most likely changes the mass of an unstable nucleus? Is it letter A, beta minus decay? Is it letter B, beta plus decay? Is it letter C, alpha decay? Or letter D, electron capture? And I guess that ends our 10-item pretest. So again, good morning, Happy New Year. So our topic is radioactivity. Again, I am requesting you to have your periodic table of elements with you, as that is important as we discuss our topic for today. Okay, so are you ready? Okay, you're ready. Very good. So, some atoms exist in an abnormally excited state characterized by an unstable nucleus. To reach stability, the nucleus spontaneously emits particles and energy and transforms itself into another atom. This process is called radioactive disintegration or radioactive decay. The atoms involved are radionuclides. Any nuclear arrangement is called a nuclide, and only nuclei that undergo radioactive decay are radionuclides. So, we have the term radioactivity. So, in other words, radioactivity is a form of a process to attain stability. So, yung radioactivity pala is like the current situation that we have or you have right now. Since bagong pasok ng taon, tamang-tama, timing talaga ang topic. So, you want to convert yourself from 2020 or the last year to a better or a version 2 of yourself. So, from the old you to a better you, so that is a process similar to radioactivity. Or pwede din namang being a radtech student into a professional radtech, so posible yon to attain stability in your life. Ganon din pala ang atom. If an atom is unstable, so mag-undergo siya ng process. So, yung process na yon involves emission of particles as well as energy, and then nagtatransform siya from one atom into another atom para maging stable. And again, that is radioactive decay or radioactive disintegration. Radioactivity kasi there is a form of emission of energy. Kaya radioactive. So, hindi naman lahat ng atom nag-undergo ng radioactivity. Only those that are in excited state. Ano? Kasi yung ibang atom are already stable. So, only radionuclides undergo radioactivity. So, paano nga ba natin malalaman that a certain atom is radioactive or is not radioactive? Ito yung kasagutan. So, many factors affect nuclear stability, and perhaps the most important is the number of neutrons. When a nucleus contains either too few or too many neutrons, the atoms can disintegrate radioactively, bringing the number of neutrons and protons into a stable and proper ratio. Sabi dito, pag ang number ng neutrons maging equal sa number ng protons, we can say that that atom is already stable na siya. So, hindi na siya mag-a-undergo ng radioactivity. So, mostly, sa ating periodic table of elements, those that are in the group 8 are noble gases. Minsan tinatawag din natin yung mga stable elements. But hindi lang yon yung mga typical example natin. So, bigay tayo ng isang element na medyo madali nating ma-memorize. Ano? So, for example, we have 12, carbon. So, we know for a fact that carbon is the 6th element. And as a review again, so, sa left superscript, this is the atomic mass number, and the left subscript, this is the atomic number. So therefore, we can say that carbon has 6 protons. Again, remember that the atomic number is the number of protons, and sinabi natin na atomic mass number is the combination of protons and neutrons. So therefore, to find for the number of neutrons, we will subtract the atomic mass number minus the atomic number. 12 minus 6. So, therefore, the number of neutrons is 6. So, sanabi natin kanina, pag maging equal ang number ng proton at saka neutron, neutron at saka proton, ano ka ba, sir? So, that atom is already stable. So, dalawa lang yung subatomic particles na may direct or may connection sa stability ng atom. Ano ulit yon? Of course, the neutrons and the protons. Ayun. So, I guess may mga marirealize na kayo from the pre-test. Okay? Sige, ano pa? Ano pa yung mga characteristics? So, in addition to stable isotopes, many elements have radioactive isotopes or radioisotopes. These may be artificially produced in machines such as particle accelerators or nuclear reactors. Artificially produced radioisotopes have been identified for nearly all elements. Examples of artificial radioisotopes include the 7 radioisotopes of barium with atomic mass number from 127 up to 140. And of course, the cobalt-60. So, nang mag-search ako ng particle accelerator or nuclear reactor, ito yung binigay niyang picture. And to be honest naman, it's good to be true. Hindi pa ako nakakita ng actual particle accelerator or nuclear reactor. Pero I can imagine parang ganun yung itsura niya, no? Okay, so artificial na naproproduce minsan ang radioactivity based sa ating nabasa. So, using the particle accelerators or nuclear reactors. So, let's take for example, cobalt-60. So, si cobalt is a byproduct of artificially produced radioisotope. From cobalt-59, bobombahan siya ng neutrons. Of course, using nuclear reactors or particle accelerators. Para si cobalt-59 magiging cobalt-60 na siya. Yun. So, that's a form of artificially produced radioisotope. So again, may mga example tayo dito, barium and cobalt. So artificial or man-made na pag-produce ng radioactivity. Of course, kung may man-made, there's the counterpart, natural, yung gawa ni inang kalikasan. So a few elements have naturally occurring radioisotopes as well. So there are two primary sources of naturally occurring radioisotopes. Some originated at the time of the Earth's formation and are decaying very slowly. Ang tawag natin dyan sa kanila is primordial radiation. Ginagawa pa lang yung Earth, nandun na sila, mga radioactive sources na yon. So primordial radiation. An example is uranium, which ultimately decays to radium, which in turns decays into radon. So from uranium, nagiging radium, at saka nagiging radon. So others such as carbon-14 are continuously produced in the upper atmosphere through the action of cosmic radiation. Ito, yung tinatawag naman natin dito sa kanila is the cosmogenic radiation. Kasi from cosmic rays or coming from the sun, nag-i-interact siya or the carbon-14 interacts with the cosmic rays coming from the sun. Kaya tawag dyan, cosmogenic radiation. Anyways, hindi naman kayo ganun ka-excited when maging third year kayo, we are going to discuss them. Yung primordial at saka yung cosmogenic radiation. Anyways, it's already downloaded naman in my YouTube account. Nag-plug pa. Okay, so again, kung mayroong artificial, so mayroon din namang natural or gawa ni inang kalikasan. No? So radioisotopes can decay to stability in many ways, but the beta emission and alpha emission are important here for descriptive purposes. Actually, the application applies to the radiologic technology profession, dalawa yung may direct bearing, yung beta emission at saka alpha emission. So radioactive decay by positron emission is also important for some nuclear imaging or nuclear medicine imaging. Okay? So, for example, kasi baka ma-assign kayo sa nuclear medicine department, may mga tinatawag dong mga radioisotope na purely beta emitter. At least you know what is beta emitter. Meron din namang both gamma and beta emitter. So, para mas maintindihan natin ang process ng radioactivity, so we will discuss the 8 types of radioactive decay. Una, we have alpha decay, we have beta, of course. Kasi nga sabi natin kanina, may dalawang important sa radiologic technology profession, si alpha at saka si beta emission, beta decay. Next, we have gamma. We have electron capture, internal conversion, spontaneous fission, isomeric transition, and neutron emission. I am requesting your patience, your focus, para mas maintindihan natin yung mga i-discuss natin. So focus lang muna kayo in the remaining minutes ng ating discussion. Anyways, hindi naman tumatagal para makasave tayo ng data. So let's start with okay, sige. I-review natin yung pinagsasabi natin kanina. Sabi nga natin, like you as a student, gusto nyong maging professional radtech, so it involves process, di ba? Kailangan mag-exert kayo ng energy or there's an emission of energy in a way. Particles, kung baga, nag-i-exert kayo ng mag-i-emit kayo ng mga idea. Pera? Pwede ba yun? In any ways, pwede din yun. So, radioactivity, again, is the emission of particles and energy and transformation of an atom into another atom to become stable. So, the parent nuclide emits radiation and transform into a daughter nucleus. This may be a random process on atomic level. in that is impossible to predict when a given atom will decay, but given a large number of similar atoms, the decay rate on average is predictable. Okay, so next week, probably, may tinatawag din namang half-life. There's a certain period of time, kaya predictable siya. Okay, by the way, so as a review ng atomic nomenclature, ano po? So, X, that designates the element. A is the atomic mass and Z is the atomic number. So, kumbaga, itong side na to will now be your parent, diba? Parent nuclide. So, it converts into another atom to become stable. So, A, Z, so iba na yung element Y. Kaya sabi ko nga kanina, mas maganda if you have your periodic table with you so that we won't be guessing kung ano yung mga element na ipagsasabi natin. Ano? So, again, from here, magiging ganito siya. Kung bakit tinawag siyang parent at daughter nucleus, hindi ko na yun masasagot. Ano? So, basta ganun yung jargons na pinagtatawag nila. Parent nucleus and the daughter nucleus. So, ito yung source and ito yung bagong element. Ito ka dati, ganito ka na dati. The better, the bigger, the bolder, version 2.0. Okay. Sige, let's start with beta decay. By the way, class, beta decay has two types. Beta. So, that's the Greek letter for beta. Beta minus. Mayroon din naman tayong beta plus emission. Okay? So, tigam ni ha. So, beta rays are stream of, they are electrons from radioactive sources. Beta particles are symbolized by the Greek letter beta. So, it can travel approximately 12 feet per mega electron volt of energy in air and to several millimeter in tissue. So, it has 0.00055 AMU and a charge of -1 for beta minus particle. Ito siya. And +1 naman for beta plus particle. So, take note ha, beta particles are electrons in nature. Ang kaibahan nga lang, yung beta particles originate from the nucleus of an atom. Si electrons, nandun na siya sa mga shells, sa electron shells. Ano po? Sige, let's get to know more about the beta decay. Basta yun lang. Ay pinakilala natin that during beta decay, mag-create or magbibigay siya ng isang particle. Sabi nga natin, emission of particles. And yung tinutukoy na particle dito sa beta decay is of course the beta particle, either beta minus or beta plus particle. Sige. So, during beta minus emission, an electron created in the nucleus is ejected from the nucleus with considerable kinetic energy and escapes from the atom. The result is a loss of a small quantity of mass and 1 unit of negative electric charge from the nucleus of an atom. So, simultaneously, a neutron undergoes conversion into a proton. Again, do not be confused here. We are talking with the beta minus emission, in which we said that a neutron will now convert itself into a proton. Ano? And at the same time, magbibigay siya ng isang electron or a negatively charged particle that is ejected or ibibigay nanggaling sa nucleus ng atom. So, of course, as a result, there is a loss in the quantity of mass and 1 unit of negative electric charge. Kaya beta minus decay. Sige, ano pa? So, the result of beta minus emission is therefore to increase the atomic number by 1 while the atomic mass number remains the same. So, this nuclear transformation results in changing of an atom from one type of element into another. So, ganito na lang. Para mas madali niyong maintindihan, bibigyan ko na lang kayo ng hint or clue. So, pag sinabi nating beta minus, siya lang ang minus sa buong mundo na may addition. Ano? Beta minus pero nag-plus. Imdala, oh. Di naman beta plus or positive decay pero na minus in 1. Yan. Sige, unahon ta sa beta minus emission. Again, for example, we have here carbon. Let's say carbon 12. Carbon 13 na lang, 13. Carbon 13. Carbon has, okay, so gawas an EU periodic table of elements. Hindi nakita, huy. Okay, so carbon 13, ano na aton atomic number ng carbon? So hydrogen, helium, lithium, beryllium, boron, carbon. So that's the 6th element. So 6. So mag-undergo siya ng beta minus. So we said that in beta minus emission, so atomic number is increased by 1 while atomic mass number is the same. Atomic number increased by 1. So, 6 plus 1, that will become, alang pa man mag-calculator, so that will become 7. So, atomic mass number remains the same. 13 pa din siya. So, what is now the element number 7? Diba? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. So, the 7th element is nitrogen. So, this is the parent nuclide. This is now naman the daughter nuclide. Diba? So, it changes from one type of element into another. So, again, nag-add tayo ng 1 in the atomic number but the atomic mass number remains the same. Maula ito ang beta minus nga na plus. Nga din naman kita sa beta positive decay. In beta positive decay, okay, a proton undergoes conversion into a neutron. So, kaya siya maiibanan. Ano? Kasi si proton, nga nagdadarahan atomic number, so may ibanan usa. Kasi magiging neutron siya. So, a positron is ejected, positron or a positively charged electron is ejected out of the nucleus. So, this results to decrease atomic number by 1 while atomic mass number remains the same. So, bago naton, kanina na, an example naton, balikon tala. Sige, gamiton tahi, 13, tapos 7. Yan, nitrogen. Mag-undergo siya ng beta plus decay. So, the result again is to decrease atomic number by 1. So, 7 minus 1, alang pa man, mag-calculator, that is 6. So, atomic mass number remains the same, 13. So, the 6th element is carbon. Ayun. So, nakuha. Okay, very good. So, now let's go to alpha decay. Alpha decay. So, dito sa alpha, we have, kung kanina, we said that beta particle is an electron. Dito naman, we have that alpha particle. Yun. Sige, atronta. An alpha particle is a helium nucleus that contains 2 protons and 2 neutrons bound together. So, pwedeng stop ko lang muna ha. So, ito yung example ng alpha particle. So, yung red dito indicates proton and the blue indicates neutron. So, si alpha particle, meron siyang 2 proton at saka 2 neutron, which is similar to helium nucleus. Pansin nyo, 4. Atomic mass number is 4. So, therefore, meron siyang 2 protons and of course, 2 neutrons. Same as true sa sa alpha particle. 2 protons at 2 neutrons. So, its mass is approximately 4 AMU and it carries 2 units of positive electric charge. Compared with an electron, the alpha particle is large and exerts great electrostatic force. So, alpha particle are emitted only from the nuclei of heavy elements. So, ikat ko lang muna dyan. So, it is emitted from the nuclei of heavy elements. Nucleus ng heavy elements with atomic mass number greater than or equal to 150. Below 150, hindi na siya capable na mag-emit ng alpha particle. Tigam niya. So, pag maimod niyo ang left superscript nga lower than 150, di rin siya pwede mag-undergohin alpha emission. Ano? So, kailangan the left superscript or the atomic mass number should be 150 or above. Light elements cannot emit alpha particles because they do not have excess mass or excess energy. Yun. So, ano naman yung process ng alpha decay? So, radioactive decay by alpha emission is a much more violent process. Tindi to. So, the alpha particle consists of 2 protons and 2 neutrons bound together. Its atomic mass number is 4. So, a nucleus must be extremely unstable to emit alpha particle. But when it does, it loses 2 units of positive electric charge and 4 units of mass. So, the transformation is significant because the resulting atom is not only chemically different but is lighter by 4 AMU. So, balikan natin si parent at saka daughter nucleus. So, si atomic mass number at saka si atomic number. So, sa alpha emission, si atomic mass number will now be minus 4 at saka si atomic number minus 2. So, different element na siya. Okay? Okay. Sige, let's have an example kaya sa alpha. Sige nga, kung wala ng ibang slide. Okay, sige, ito muna. Beta emission occurs much more frequently than alpha emission. Virtually, all radioisotopes are capable of transformation by beta emission. But only heavy radioisotopes, sinabi natin kanina, atomic mass number greater than or equal to 150 are capable of alpha emission. Some radioisotopes are pure beta emitters or pure alpha emitters, but most emit gamma rays simultaneously with the beta particle emission or alpha emission. Okay, so si gamma daw, mas sumasama siya with beta or alpha emission. Sige, unahin muna natin si alpha because later we will discuss gamma. So for example, we have yung example natin kanina doon sa mga primordial radiation, di ba? We have uranium 238. So, pasok ba siya na mag-emit ng alpha particle? Mas mataas ba yung atomic mass number niya sa 150? Of course, 238. Pasok na pasok. So that we will not be guessing kung ano yung atomic number, sige, kukunin nyo yung periodic table of elements nyo. Hanapin nyo si uranium. Anong number or ano ang atomic number niya? Pang ilang element? So, pang 92. So, mag-undergo siya ng alpha emission. Anong mangyayari? So, 238 minus 4. Sinabi natin kanina. So, 238 minus 4. Magka-calculator pa ba? So, that will become 234. So, 92 minus 2. Magka-calculator pa ba tayo? So, 92 minus 2, that will become 90. Now, identify mo ano yung element or element number 90. Ano yung element na may atomic number ng 90? So, that is yung paboritong element ng mga girls, si Thor. Thorium. So, from uranium-238, pag mag-undergo siya ng alpha emission, magiging thorium-234. Okay? Are there any questions? If you have, of course, do not hesitate. So, we have different platforms to do that. Alam nyo na yan. Okay, so I assume nakuha nyo na yung beta emission at saka yung alpha emission. So let's proceed with gamma emission. So gamma is one type of radioactive decay that a nucleus can undergo. What separates this type of decay process from alpha or beta decay is that no particle is ejected from the nucleus when it undergoes this type of decay. Instead, a high energy from or form of electromagnetic radiation, ayun, so pumasok dito si electromagnetic radiation, which is a gamma ray, is released. So, may I cut lang muna dyan sa statement na yan. So, class, we have two known types of electromagnetic radiation. So, isang gamma at saka isang X-ray. Okay? So, during radioactivity, si gamma yung papasok na electromagnetic radiation. Iba yung production ni X-ray, which is, of course, kasi nga yung subject natin, radiation production and characteristics. So, isang type ng electromagnetic radiation that is being produced in this radioactivity, kaya tinawag siyang radioactivity kasi nga may radiation because there's the presence ni gamma ray. Okay? Tara natin. So, what separates this type of decay process from alpha or beta decay is that no particle, hindi siya nag-i-emit ng particle, only nag-i-emit lang siya ng energy or electromagnetic radiation. So gamma emission is unique in the sense that the undergoing gamma decay does not change the structure or composition of the atom. Instead, it only changes the energy of an atom. Since gamma carries no charge nor does it have associated mass. Kasi it's a form of energy. Gamma radiation. Wala siyang mass. Hindi kasi siya particle. By the way, si beta, since sinabi nating electron siya at saka yung alpha, kasi sinabi natin na mayroon siyang 2 protons and 2 neutrons bound together, they are forms of particulate radiation. Si gamma at saka si X-rays, they are forms of electromagnetic radiation. They have no mass and no charge. Okay? So, as you can see in our illustration, nag-undergo ng decay pero same pa din yung pagmumukha ng atom. Nag-emit lang siya ng photon or electromagnetic radiation. And that is gamma radiation, gamma emission. Okay, so in order for a nucleus to undergo gamma decay, it must be in some sort of excited energetic state. Unstable din dapat yung nucleus ng atom na yon. Thus, if a proton or neutron inside the nucleus jumps up to an excited state, generally following alpha or beta decay, the new daughter nucleus must somehow release energy to allow the proton or neutron to relax back down to ground state. So, ito pala class yung nagiging unique kasi si gamma, pumapasok lang siya pag mayroong alpha or beta decay. Hindi siya solo na emission. Wala namang tinatawag na purely gamma emitter. Pumapasok lang siya or sumasama siya kung mayroong alpha or beta decay. But sinabi natin kanina, there are elements sa nuclear medicine na purely beta emitter. And meron din namang both gamma and beta emitter. Merong alpha emitter and gamma emitter. So, hindi siya solo na emission. Sumasama siya with alpha or beta decay. When the nucleon makes this transition from a high to low energy state, a gamma photon, of course, is ejected photon or an electromagnetic radiation. Okay? Okay. Ay, salamat. Nasa pang-apat na tayong emission. We have electron capture. So, meaning nangkikidnap pa ito ng electron. This is a process in which the proton-rich nucleus of an electrically neutral atom absorbs the inner atomic electron, usually from the K or L electron shell. This process thereby changes a nuclear photon to a neutron and simultaneously causes the emission of an electron neutrino. Okay, class? So, kasi nga sabi natin kanina, there are two subatomic particles na may direct bearing with stability, di ba? Pag neutron rich or proton rich. Hindi balance kasi, di ba? Pag hindi balance ang number ng neutron at proton, so nagkakaroon ng radioactive disintegration. In electron capture kasi, marami siyang protons. So gusto niyang mag-convert ng isang proton into a neutron. And magagawa lang niya yun kung magkikidnap siya ng isang electron from the orbit. So, in this process again, a proton is converted into a neutron. But, kailangan niya munang kumuha ng electron. Para maging neutral siya, proton kasi positive, kukuha muna siya ng negative bang. Magiging neutron siya. However, there is an emission of electron neutrino type of particle. So, what follows after electron capture is that the atomic number is reduced by 1. The neutron number is increased by 1, di ba? Sabi natin kanina, ang isang proton naging neutron. So, therefore, the atomic number is reduced by 1 because the neutron number is increased by 1 and there is no change in mass number. So, parang may kaparehas siyang process or emission. Parang may kaparehas siya. May naalala ba kayo sa electron capture, di ba? Parang similar siya dito. So, similar siya sa beta plus emission or beta positive decay. Kasi sabi natin sa beta plus decay or beta plus emission, plus siya pero nagmaminus siya ng isang atomic number. So, sabi natin sa electron capture, saan na ba yun? Diba? The atomic number is reduced by 1, but the atomic mass number is unchanged. So, simple electron capture by itself results in a neutral atom since the loss of the electron in the electron shell is balanced by a loss of positive nuclear charge. However, a positive atomic ion may result from Auger-electron interact or emission. Class kasi, that is an abnormal condition of an atom if there is an inner shell void. Pag bakante yung inner shell, especially K or L shell, abnormal yung atom. So that will be corrected by transition of an outer shell electron. Halimbawa ito, bakante yung K shell, bababa yung L papunta sa K. Of course, magkaibang energy level yun eh. So from a higher energy level, bababa siya. So therefore, there is an emission of energy. And in a way, that is what we call now here the Auger electron. Electron lang pagka-term niya, but that is a form of energy. So do not be confused. So electron capture is an example of weak electron interaction. By the way, here, that Auger electron is actually in a form of characteristic characteristic radiation. Ayun naman pala. So, may mga naalala na kanina based sa pretest. So, again, electron capture is an example of weak interaction, one of the 4 fundamental forces of nature. So, now let's come to internal conversion. Okay? So, a radioactive decay process wherein an excited nucleus interacts electromagnetically with one of the orbital electrons of the atom. Sabi natin kanina, di ba? Dapat conversion or the process is in the nucleus. So, meron naman, di ba? The nucleus interacts electromagnetically. May nilalabas siyang photon galing sa nucleus na nakipag-interact siya sa orbital electron. And that this causes the electron to be emitted or ejected from the atom. Thus, in an internal conversion process, a high-energy electron is emitted from the radioactive atom. But take note that electron does not come from the nucleus. And for this reason, the high-speed electrons resulting from internal conversion are not called beta particles, since the latter can come from the beta decay, where they are newly created in the decay process. So, kung baga, anong tawag nito? Parang hindi niya nagugustuhan yung electron, kaya nakipag-interact siya doon para itapon palabas sa atom ng element. Ano? Ganon yung, ganon yung nagiging picture. Parang may hindi magandang pangyayari sa loob ng atom na parang nandoon sa electron. Kaya yung nangyari, itatapon yung electron palabas ng atom. And that is internal conversion. Walang direct bearing sa nucleus. So, internal conversion is possible whenever gamma decay is possible. So, yung electromagnetic radiation na pala yun is coming from the gamma. Except in the case where the atom is fully ionized. So, during internal conversion, the atomic number does not change, and thus, as is the case with gamma decay, no transmutation of an element to another takes place since an electron is lost from the atom. So, a hole appears in the electron shell, tulad nangyari sa electron capture, which subsequently filled by other electrons that descends to that empty, lower energy level, and in the process, that emits characteristic radiation, either Auger electron or both. So, the atom thus emits high-energy electron and X-ray photons. So, pumapasok na dito si X-ray. Kasi, sige, ganito na lang. Kasi si gamma, actually, electromagnetic radiation siya. Pero, the origin is from the nucleus. Si X-ray kasi, ang origin niya is from the electron shell. Kaya, papasok na dito si X-ray. Posible with an internal conversion because the emission of Auger electron or characteristic radiation is from the orbital electron shell. Nakuha? I thank you. Ang galing talaga ng mga BSRT2 students. Okay. The atom supplied the energy needed to eject the electron, which in turn caused the latter events and the other emission. So, yon. That's internal conversion. Pang ilan na ba to? I guess pang 5. So, now let's come to spontaneous fission. So, kung maaalala nyo, there is fusion. Fusion, nag-fuse yung mga maliliit na nucleus. Yung fission naman, naghihiwalay ang malaking nucleus into smaller nuclei. Mas maraming nucleus, kaya fission. Yan. So, spontaneous fission, it is a form of radioactive decay that's only found in heavy or very heavy chemical elements. The nuclear binding energy of elements, its maximum at an atomic mass number about 58. So, mas mataas pa din yung alpha kasi sa alpha is 150 yung atomic mass number. Spontaneous breakdown into smaller nuclei and a few isolated nuclear particles becomes possible at greater atomic mass numbers. So, what else? Because of constraints in forming the daughter fission product nuclei, spontaneous fission into known nuclides became theoretically possible. That is, energetically possible for some atomic nuclei with atomic masses greater than 92 atomic mass unit, with the probability of spontaneous fission increasing as the atomic mass increases above this value. Mas tumataas yung atomic mass number, mas malaki ang chance na magkaroon ng spontaneous fission. Okay, so take note again class ha. Spontaneous fission is from atomic mass number 58 up to 92. Whereas alpha, with atomic mass number greater than or equal to 150. Okay, sige. Now, let's come to isomeric transition. Isomeric, di ba? Do not forget the isomer, one of the atomic nomenclatures, along with isotopes, isobars, isotones. So, merong isomer. So, an isomeric transition is a nuclear process in which a nucleus with excess energy following the emission of an alpha particle or beta particle emits energy without changing its number of protons or neutrons. Isomeric transition can occur through emission of a gamma ray or through internal conversion. So, sabi dito, isomeric transition happens after either beta emission or alpha emission. So, let's consider itong process na to, nag-undergo siya ng either alpha or beta emission. So, nandito yung tinatawag nating isomeric transition. So, mag-change, hindi naman mag-change. Kasi isomer, di ba? Same number of protons, same number of atomic number and same atomic mass number, but they are in different energy states. Kaya nga, yung illustration natin, hindi siya magkahiwalay na path. Same path lang siya. Kasi iisang atom pa din yan. Diba? Sige. In certain cases, the excited nuclear state following the emission of a beta particle may be nearly stable and the nucleus may be able to stay in this nearly stable state for minutes, hours, or even days or before emitting a gamma ray. So an isomer, as it is called, behaves as a separate radioactive material decaying exponentially with the emission of gamma ray only. An example is technetium-99m, which is produced when molybdenum-99 emits a beta particle. Halimbawa dito, molybdenum-99 nag-emit ng beta particle. So, what follows next is nag-convert siya into technetium-99. Okay, so molybdenum, C. Element number 42 or the atomic number is 42, whereas the technetium is or has an atomic number of 43. So therefore, nag-undergo siya ng beta minus emission. Ano? So, after that, mag-undergo siya ng isomeric transition. And then kasi hindi pa siya ganun ka-stable, so nag-undergo pa siya ng another emission. Ayun. Okay, so we have the last. Ay, salamat. So, the neutron emission. It is a type of radioactive decay of atoms containing excess neutrons in which a neutron is simply ejected from the nucleus. So, ikakat ko lang muna dyan. Kasi, parang magkaroon tayo ng simple analogy. Halimbawang yung klase nyo, BSRT2. So, it's already the nucleus. So, may mga neutrons. Let's take for example, each of the BSRT students ay mga neutrons inside the nucleus. So, hindi pala lahat sa inyo gustong mag-radtech. So, with neutron emission, yung ibang hindi gustong mag-radtech, itatapon. Kasi nakakaabala lang. Nakakabigat, nagiging unstable yung klase. So, yung iba itatapon na lang papunta sa ibang university, sa ibang school para mas maging stable, mas matatag ang BSRT2. Kaya, kung lumabas kayo dyan sa BSRT2, magtaka na kayo. Baka kayo ang mga pabigat sa BSRT2. Sige. Okay, neutron emission is one of the ways of atom reaches its stability. An atom is unstable, therefore radioactive, when the forces in the nucleus are unbalanced. So, the instability of the nucleus results from the nuclei having extra neutrons or extra protons. So, sabi ko nga kanina, yung isang neutron dyan, itatapon na lang. Kasi pabigat lang siya sa nucleus. Okay, so after that, as only a neutron is lost in the process, the atom does not gain or lose protons and so does not become an atom of different element. So, nag-change lang siya sa atomic mass number, not in the atomic number. So, instead, the atom will become a new isotope of the original element. Example, beryllium-13 becomes beryllium-12 kasi nagtapon siya ng isang neutron after emitting one of its neutrons. Okay. So that ends my discussion. I hope you learned something even though we are just in a virtual setup. So if you have queries, if you have questions, do not hesitate ha. Kasi sa akin din naman yan babags. Ako din naman yung blame kung bakit hindi kayo natuto. So let's help one another after watching this video. So mag-question kayo either sa ating group chat, sa ating chat in the Moodle, through personal text, or even in this YouTube video, pwede nyo gawin yon. Okay, so let's check your answer. Kunin nyo yung papel nyo kanina at malalaman natin kung tama ba yung mga sinagot nyo. Number 1, electron capture has a similar result with blank emission. So sabi natin kanina, with electron capture, the atomic number is decreased by 1, whereas the atomic mass number remains the same. And that is similar with beta plus emission. Diba? Okay. Sige, next. Number 2. Emission resulting when a proton undergoes conversion into a neutron. So, proton undergoes conversion into a neutron. So, therefore, mababawasan ang isang atomic number. So, take note class ha, yun lang yung plus na nagbabawas. Kaya, the answer is beta plus emission. Okay? Kasi, again, mag-change ang proton into a neutron, mababawasan ang atomic number. At ano yung plus na nagbabawas? Therefore, that is beta plus emission. Next number 3. So, cobalt-60 decaying into nickel is an example of. So, if you have the periodic table with you, so mapapansin nyo, cobalt is element number 27. Nickel is element number 28. So, take note class kung ano yung minus na nagdadagdag, di ba? Minus siya pero nagdadagdag. So therefore, nadagdagan ng isa yung atomic number niya, so beta minus emission or beta minus decay. The answer is B. Okay, number 4. The following emission tends to decrease atomic number by 1. So, ano yung plus na nagbabawas? Pero may sinabi pa ditong except. So, yung pipiliin natin is hindi nagbabawas bagkus yung dumadagdag ng isa. So, yung minus na nagdadagdag, that is beta minus decay. Sige nga, double check natin. Beta positive decay, ano yung nangyayari sa atomic number? Di ba nababawasan? Positron emission, ano nangyayari? Di ba nababawasan? Electron capture, ano nangyayari? Di ba nababawasan? So, our correct answer is letter B. Okay. Sige di ba? Kalain nyo yun. Nasa number 5 na tayo. So, which of the following is least likely to undergo radioactivity? Kasi nga, sinabi natin kanina, pag same ang number ng proton at saka neutron, that is already considered as stable. So, yung naging example natin kanina is carbon-12. So, therefore, our answer is also carbon-12. Next number 6. Akalain nyo yun. So, the following subatomic particles determine the stability of all atoms. So, sabi natin kanina, kailangan or pag naging equal ang number ng neutron at saka proton, that is now considered as stable. So, walang pakialam si electron. So, 1 and 2. Therefore, our answer is letter A. 1 and 2 only. Next number 7. It is the Auger electron emitted during the electron capture. Sinulat ko pa yan kanina. So, Auger electron, this is a form of energy, di ba? During the transition, kasi bakante na yung K shell, pupunta yung L shell, papunta sa K shell, therefore, mag-i-emit siya ng energy or ng radiation, which is what we call the characteristic radiation. Number 8. Blank is the electromagnetic radiation released during transition of a daughter nucleus from an excited state to the ground energy level. So class ha, sinabi natin kanina, may dalawang uri lang ng electromagnetic radiation. So therefore, ikra-crush out natin yung mga particulate radiation. Hindi kasama dito si alpha at saka beta. So the choices is between gamma and X-ray. And sinabi natin kanina that yung origin kasi ng X-ray is in the electron cloud, whereas yung origin ng gamma is in the nucleus. So therefore, our answer is of course gamma. Next number 9. The radioactive disintegration that results in characteristic radiation. So, yung nagbibigay ng characteristic radiation, beta minus, may characteristic radiation ba? Wala, di ba? Beta minus particle lang. Yung beta plus emission, wala, di ba? Positron lang. Yung alpha emission, wala. Kasi ano lang siya, di ba? Alpha particle. So, the best answer here is electron capture. And the last number. Which of the following decay modes most likely changes the mass number of an unstable nucleus? Beta minus, nag-change ba yung atomic mass number? Diba sabi natin, same pa din yung atomic mass number. Beta plus, sinabi din natin, same pa din yung atomic mass number. How about alpha decay? Diba sa formula, A minus 4 and Z minus 2 para maging bago siyang element. So therefore, siya ang best answer. Let's check. Electron capture. 'Di ba parehas yung result niya sa beta plus decay? So atomic mass number will be the same. Kaya the answer is alpha decay. And that ends my discussion. So if you have questions, again, do not hesitate. And that dito na lang tayo, and thank you so much for watching. God bless, and again, Happy New Year. Goodbye.